Welcome back to the channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. There is a boundary that Remo will never cross, no matter how hard one may try. It seems that even with science fiction technologies, we are trapped in a limited pocket of the universe with unlimited objects within it. The Milky Way, our galaxy, is a cosmic colossus with a diameter of up to 200,000 light-years and hosts up to 400 billion stars. Yet, the universe we live in, which contains about 2 trillion galaxies, presents us with an insurmountable limit. About 94% of the galaxies are unreachable, confined beyond our cosmic horizon due to the acceleration of universal expansion. Our local group, a collection of over 50 galaxies including the Milky Way and Andromeda, represents our pocket of the universe. But as the expansion of space increasingly pushes other galaxies away from us, 90% of the galaxies observable today are irretrievable and beyond our reach. This perpetual motion makes all these galaxies unreachable, and therefore, they are already out of our reach. Why do galaxies exist in the first place? A few seconds after the Big Bang, the young universe was a very small bubble of energy, but it was not completely uniform. Some parts of it were slightly denser than others, which had gigantic consequences during a process called cosmic inflation. The observable universe expanded rapidly, from the size of a marble to thousands of billions of kilometers in a trillionth of a second. So rapidly that all those small differences in density were stretched from subatomic distances to galactic distances. This is why the entire universe is composed of regions that are more and less dense, pockets of universe filled with a bit more matter compared to the space around them. After the end of the brief but powerful inflation, gravity began to try to pull everything back together into the denser pockets. Gravity prevailed, and over time, these became groups of galaxies, like the local group we live in today. On larger scales, outside the denser pockets, the expansion of space has never stopped. This means that our local group is surrounded by several other galactic structures, but none of these are gravitationally bound to us. As the universe expands, the distance between us and other gravitational pockets grows larger. Even worse for us is that the expansion of the universe is accelerating, a phenomenon we do not fully understand and for which we have developed the concept of dark energy, an invisible effect that accelerates the expansion of the universe. This expansion means that there is a cosmic horizon around us. Everything beyond it is traveling away from us faster than the speed of light, so anything that passes the horizon is hopelessly out of reach forever. We will never be able to interact with it again. In a sense, it's like the event horizon of a black hole, but all around us. 90% of the galaxies we can observe today have already passed it and are lost to us forever. Although the speed of light is the fastest way to travel through the universe, it takes time to get from one place to another. Every second, light reaches us from thousands of billions of galaxies that have passed the horizon because, when their light was emitted, they were much closer to us. We are observing their ancient past and seeing their ancient positions. Thus, the observable universe is much larger than the universe we can actually interact with. In a sense, the universe is staging a grand show for us, showing us things that are out of reach forever. We have no idea what these galaxies look like today and we will never know. However, we will be able to observe them for a long time, as long as their light continues to reach our telescopes. Curiously, this means that the observable universe currently appears to be still growing, as more and more light emitted by super-distant galaxies, billions of years ago, is arriving at our doorstep. However, all the pockets of the universe outside the local group will one day pass our cosmic horizon. Once they have done so, their light will no longer be able to reach us and, from our perspective, they will vanish into darkness. Every second of your life, 60,000 stars pass the horizon. But if 90% of the observable universe is beyond the cosmic horizon and lost forever, that still leaves 10%, technically within our reach, and that's still a lot to see. All the galactic pockets that are less than 20 billion light-years away are still moving away, but slowly enough that we can physically reach them. Although the chances are decreasing every second, everything more than about 5 million light-years away is moving away from us. The challenge is extreme, however, even for Type 3 civilizations, even at the speed of light. A trip to the Maffei group, the nearest galactic pocket outside the local group, would take 10 million years. If some super-motivated and super-advanced civilization accepted the challenge, their potential sphere of influence could expand to hundreds or thousands of galaxies. It's fairly safe to assume that humans will not undertake this journey, at least not with technologies that are even remotely on the horizon for us. The local group is most likely the largest structure we will ever be part of. Just traveling between stars would be an achievement of epic proportions, and it would already be a great accomplishment if we managed to colonize our solar system, which consists of a nano part of the observable universe. As dark energy pushes the rest of the universe away from us, the local group will bind more tightly. All its galaxies, large and small, will merge together to form a gigantic elliptical galaxy with the rather unoriginal name of Andromeda. In a few billion years, this process might even cause huge clouds of gas to collide and reignite star formation for a while, and this new light will indeed be welcome. Because at some point, the galaxies outside of Andromeda will become so distant as to become too weak to detect. Once that happens, no information outside the local group will ever reach us again, and the universe will escape our view. A being born in the distant future in Andromeda will think the universe consists of nothing beyond their own galaxy. When they look far into space, they will see even more emptiness and darkness. They won't see the cosmic microwave background and will be unable to know about the Big Bang or understand the nature of the expanding universe, how it began, and how it will end. They might think the universe is static and eternal. Andromeda will become an island in the darkness, gradually becoming darker still. Yet, with its 1,000 billion stars, the local group is certainly a playground big enough to entertain humanity for a while yet. After all, we haven't yet left our solar system and we have dozens of billions of years, at the very least, to explore our galaxy. In conclusion, the exploration of outer space remains a daring and challenging enterprise for humanity. The vastness of the universe and its limits imposed by physical laws, such as the accelerated expansion and the cosmic horizon, make every space conquest a significant milestone. As we move toward the future, our understanding of the universe may change with new discoveries, but for now, the local group represents the ultimate boundary of our cosmic adventures.